Okay, hey everybody. This is Andrew from Design Point. I'm here today with Andrew Reuther, a SolidWorks designer who I'm going to call a power user. He called in to support the other day. He had some really cool stuff that he was working on for some custom car parts. And I'm always on the lookout for people to share some of the really cool things that they're working on with SolidWorks. I had been doing some surfacing recently for some other customers. I figured that this was maybe a pertinent topic for people out there. So I wanted to ask him if he had any designs that he was willing to share, talk a little bit about what it took to make those into reality. And he agreed. So here today with us is Andrew Reuther. Welcome.
Thank you. How are you?
Good. How are you?
Good, good. Just enjoying the sunny weather.
Oh, yeah, that's right. He's down in Florida right now, or that's where he's based out of. Hey, so can you just give us the elevator version of your introduction? What's your interest? What's your experience? Why are we talking to you today? All that kind of fun stuff.
Well, my interest, that's a deep question. It started when I was a little kid. Love cars. So basically my mind and creativity are not necessarily centered on cars, but things that go fast, things that are enjoyable.
Wait, that's right. You also have some interest in motorcycles.
Yeah, so I'm wearing this shirt on purpose. That's the P-51 Combat Fighter. That was one of the early designs that I worked on.
Nice.
And that was back in 2014 and 2015. And that was during a little stint in Alabama. Had a lot of fun. It was a really good time. But
so if people see this video and they need like custom designs for motor vehicles of any type, boat, plane, automobile, scooter, call you.
It's not limited to any of that. It's if you have an idea, you don't have an ability to actually develop it, give me a shout, and I'm happy to help if I can help.
Awesome.
So, yeah.
So you have something prepared to share with us today?
Yes, sir.
All right. Let's see it.
All right. So what we're looking at here, this was a company that I worked with, for the last almost 8 years. Company's called Reusang. You can check them out at reusang.com.
Okay.
They basically specialize in performance automotive accessories, everything from tow hooks. This is a particular titanium shift knob that we developed. And you just look there and then you basically have a product for your car. If it's manual or even automatic, it'll probably work.
Okay, sweet. So this is the shifter.
Yes, sir. This is a titanium shift knob. They basically cut these out of an ASTM B348 grade. Well, this one says grade 2, but it's a grade 5 titanium. And then they come in all sorts of finishes. And part of that program was, they'll go all the way back to the beginning, which I'll show you that.
Okay.
Let's go here.
Okay.
So they'll start with a blank, which looks very similar to this.
Yep.
You can turn off the tangency lines to get a really good idea of what that form looks like. You see a little bit of change in the surfacing there between here and here.
Yep.
And they'll finish this in any which way, whether it's sandblasted, whether it's a black, anodized, or even burnt. So burnt titanium is always the hot number. It has a nice rainbowing effect that's controlling the titanium oxide that develops on the surface. So the idea or concept that I saw the potential of was, hey, it'd be great to have like a post machining feature in a finished product that was a little different, and this is how that really starts. Okay. So obviously it's a matter of creating basically a base surface to reference from.
Okay, so just to be clear, so this is all so once you're done with this product, this is going to be exported to CNC. This is a blank that you're going to actually carve out. This isn't stickers. This isn't post-processing welding or anything like that. This is actually just this blank material. You're going to carve out of it a custom shape, and you even have the logo right there.
Yep.
Okay.
So, and essentially what that is, I mean, obviously, yes, it is CNC machined, and it's all in-house, which makes, it was really cool to work with a company to, hone in on that manufacturing process, because one of the biggest challenges that any designer will face in the future is going to be to design for manufacturing. So if you understand the manufacturing process, you can realize any design that you have in your heart or your mind. Because one of the dangerous pitfalls you'll come across is designing something that looks brilliant, but then an engineer or a manufacturer will look at it and says, that looks great. I can't build it. I can't cut that. These features are not manufacturable. So it's always good to have a nice, healthy understanding of, healthy boundaries of, okay, I need to design within these parameters. I know the equipment. I know how it's going to be programmed. So these all are things that will help every designer moving forward.
Okay, I'm really interested to see how you connect knowing the CNC limitations and what you're about to show us. So that is, I'm waiting. I'm excited about that.
Yeah. So again, this is a turned part. So this will be turned in a CNC lathe.
Right.
It's basically two ops. You have your op 1 and your op 2 where there's a threaded feature.
Yeah.
There's some redundant features on the underside that are basically standard for their product line, because they have a series of adapters that it's one product and it works with a external feature on an adapter, and then the internal feature on their adapter line allows it to match up to whatever car is out there. So no shifter arm is created equal, obviously. So if I have a Volkswagen shifter, it's not going to be identical to a Camaro or a Mustang. So the adapter is your bridge between a universal part, which would be this,
right,
and to whatever car you need it to fit to. Gotcha. So this being a finished product, let's hypothetically say that this part just came off of a lathe and it's ready to go. So it'll go through a finishing process to give it its appearance, whether it's a black anodized or that burnt titanium we talked about earlier. And then we have to think about, all right, well, this is my starting point. How do we put branding on it? How do we push that design? So, and then it really just goes into making the actual surfaces that create the feature that you want to see, or that you and your basic lead design or design department have dictated that, yes, this is what we want to see. So we're going into certain things here.
Can you back up to the surface offset too?
Of course. So we'll go into that. So I'm looking at this surface offset. These are the surfaces that I need to understand or to basically push back. So I'm going to take these and we'll go into, I'm just literally selecting those surfaces, but what I can do is show you a transparency here. Ooh. And then show that offset to show you what's going on there.
Oh, cool.
So, I am working with these surfaces. Okay, yes, I have a block that I'm going to try to leave alone until the very end. And there's a couple of control surfaces here. Like I've doubled up, because on the programming side, you need to have your standard blank, and that's a feature that I can just turn on and off.
Yeah.
And then
so I'm
it's
going to take a note here. So this is for anybody who doesn't have experience. So surfacing is not something that you could plug into a CNC machine. That the surfacing is infinitely small. But what you do is you use a combination of solid modeling and surface modeling. So you have a solid object that you have there, the knob, and then what he's done is he started to branch off, and it's going to come back, it's going to circle back, but he's branched off in this really neat way where he started to use surfacing, and it started with the solid model. It started with that outside shape. He was like, hey, I like this outside shape, but I'm going to take it and I'm going to copy it, and then I'm going to change it, and then I'll do some work with it, and then I'll bring it back. So that's where we're at in the process right now, and I can't wait for a couple other things because I see them coming on his design tree. So go ahead.
All right. So so we have a Revolve here, and this Revolve is actually my controller to tell me, what that machine is going to be as far as the machining depth. So right now, that's just a number. I can control that for basically ever. So when I see this, I just double click on that. I'm going to 15 thou on a depth, and essentially that's barely removing any material, because any machinist will tell you machining titanium is a nightmare. Oh. So I went to the bare minimum of what we could machine without losing design or losing that crispness that you get when you go really deep. But also you have to understand, this is a shift knob. It needs a tactile comfort. So when your fingers are on this thing, you can't have any sharp edges. There's a lot that goes into the manufacturing process, but just having that revolve, you understand how, I created that. These are just intersection curves. Yeah. And then a simple revolve to create my surface. Okay. So I have a cut extrude, and I'm referencing that created surface to hit that. So if we were to go into that one, you would see it. I'm basically taking my surface revolve and just extruding to that surface from one side. So, and that's just an offset feature. It doesn't necessarily have to be this odd number. It can be a standard 1 inch.
So you did up to the surface, but you knew that the surface was already offset so that it was the depth that the machinist, or the 15,000. So you did it, the cut extrude on the blank or the solid model, you were cutting away that material, but you used the extent of the surface.
You got it.
That's sweet. That's a really cool.
And then when we go into it, you'll see where it starts to split off. So this is just a control surface, so I can go ahead and hide that now.
Yeah.
And then I can show you what's going on here.
Yeah.
So let's see, that was.
I'm really excited about your next step where you have a delete face.
Yep. So here's your delete, and just go ahead and rebuild.
Yeah.
Because we're having.
You're good. You're good.
Is it looking good?
Yeah, this is great. So delete face is one of my favorite ways of transitioning a solid model into a surface model. So if you just start off with a square and you extrude that into a solid, rectangular prism, and I can't remember all the, engineering design terms. But if you were to delete face one of those faces, then all of a sudden you would have a hollow box that is actually a surface. And so what he's got here is that he was working on everything was solid, or wait, let me be clear. There was a solid knob, and then there was surfacing that he was starting to use. And now if he's deleted face like I think he has, then he's actually turned something into a surface model, and we'll get back, but he's just deleted something real quick. So.
Yep. So basically this is that delete face, and this was that cut feature that we used to create sort of that post machining detail start. So, and now there's a frame, and because, just a simple standard straight down cut, it's, if any designer is looking at this, you understand that a simple straight cut, it's a start, but you're not really challenging or pushing the bounds of that blend between manufacturing and design. So this is all part of that. Okay. So now we get into the boundary feature aspect of this.
Okay.
So you'll see, standard, these are just transition surfaces. So I'm starting with the basics. So just get to it.
So you did that kind of that cutaway, the delete face. Are you're saying that's for blending? So that's the art of machining and this. So those are going to be actually smooth transitions.
Not necessarily smooth, but it's so everything's about light play in my mind when I look at design. Machining has such a potential to create beautiful surfaces. So it's more or less a way to draw the eye by using light, and how a machined or tool path can go on and show you how it was programmed or how it was created. So there's a lot that goes into it, but it's really just more of that infatuation with how you actually cut materials, how you can actually achieve unique surfaces. And there's a lot of designers out there that take it to the next level. This is really, it's not rookie. but I know that there's a lot of other designers out there that use they use algorithmic base programs to create very, very unique surface blends, and those things, I mean, I'll get there eventually, but right now I'm just having a lot of fun with traditional CNC manufacturing. So
that's awesome. So all this is blending. So you were getting into the custom layers of basically like, okay, this was my shape and that was easy. And then you basically were like, okay, now let's amp it up a notch. Go ahead.
Yep, 100%. So I'm going to see if I can bring back, see, we're going to turn off the transparency. I think that's what was getting a little confusing there. So here is your one surface. So again, how you create that surface, it's really up to the designer. So me being the designer, there's no tangency, but you have those options. You understand how to use these. It's just a simple, this is a control surface. This is a starting point. So once I have it in place, I'm set. So I don't really have to make any changes there. But you'll see that as I create them, I'm not going surface to the next tangent surface. I'm controlling how I'm going to create I guess the next surface by like sort of hopscotching or going to every other surface that I know I have to create.
So it's almost framing it, like start with the easier ones so that you can frame out the harder surfaces that you
got it.
Got it.
Well, so, and that's the biggest point. You have to understand what the next surface is going to need to do. So this surface, let's face it, it looks simple, but if you started off with this, with just the one surface, with just this one guy, you're asking this next surface to guess what that end point is going to look like. So it's not really, why do that work? Why go to the extra effort? This is about time. So create the next surface as simply as you created the first surface, and then build your bridge. So
that's great. So that was a great little concept there, where you could do maybe a loft or a sweep over that entire gap, like curve it around the edge and have it extend down, and maybe it would work. But you're saying it's almost, why worth it? Why not do the solid quick win? Do as many of those quick wins, and it'll frame out the curvatures or the things that you got to wrap around, and that'll hopefully improve your success in actually accomplishing it. Yeah, got it. Because there's no award, there's no like certificate, like you figured out the most complicated thing here. It's like, do the most solid, efficient, I know this will work processes you can, right?
Yeah, and that's the other thing that I think SolidWorks does very, very well. They give you an ability to do sort of a light surface analysis just by the reflectivity of what you've established on those surfaces. But obviously in your evaluation tab, you can go to your zebra effect to see what that really looks like, or even your curvature, just so you can see, okay, I have some curvature or transition issues here going on. All right, that's fine. But if you understand the manufacturing aspect of it, you're not going to see that much curvature change from one surface to the next.
Yep.
So it's a balance of, all right, am I doing Class A? Do I need to push this any further? Not necessarily right now, because in a prototyping phase, as we did when we developed the shift knob, it was, all right, we're going to do some test cuts. We just want to see if it's an ugly surface. And when you do, there's some CAM plugins that you can do a machining preview. That helps, but when you have the equipment on site, it's great just to get to a blank, actually cut chips with all development. But again, I went just to complete it. I went all the way down. So you're seeing basically the full cap here, but again, there's more challenges here. Because one of the things that's going on is you want to control how your ball end mill walks off of a part.
Yes.
So that's more trimming, and then you get into this. So it's a nice little cancellation of a feature. You're telling the ball end mill to basically how you want it to cancel, not just a standard walk off. It needs to be designed. We're controlling all of that. So did the same on the other side.
So those are two surfaces that are actually intersecting each other completely, not just like partially like part in, but they are fully, intersecting each other. And then what he's doing is he's actually trimming them based on, hey, I want part of this surface and I want part of this surface. And then these other parts that aren't there anymore, I want those gone now. So that's exactly what we're seeing right now. So when you trim away those two, then you have the result. That's basically like a nice, like he said, it was artistic. It has the design criteria. It's everything that he wants it to be there. And that's probably how he had to, probably the challenge of that was creating the right intersection surface. Yeah.
And that's not just something that you're going to create right off the cuff by the seat of your pants, so to speak. But this is something that, you have to make sure that you're happy with that trim. And that's all basically understanding how this surface interacts with your intersecting trimmed body, which would be that guy right there. And these are things that, if it needs to be tweaked, you're going to put curvature on a surface. But right now, it was one of those things where this surface and how I created it, it was sort of organic. You have one driving edge, and then you actually have, your direction too, just to sort of help. Now, could I have done that with a the surface loft? Absolutely. I could use a surface loft feature to create that, but I wanted to start with this to see what I got out of that one feature. So again, what we talked about earlier was, you don't necessarily have to stick with a boundary surface feature. It's purely, going with what you're familiar with. So is it going to be a loft? Is it going to be a fill surface? No, not in this instance, but there's more than one avenue to go. So
first of all, what I'm learning from this is that there is so much about the process and the setup in order for you to hit the home run, to have the perfect surface. It's almost like you are setting this up. You're setting yourself up for success. And then, like I was saying, for those of you who don't know surfacing as well, there's a lot of things that he's been doing, and I've been very impressed with a lot of them. But that small curvature surface that he has there at the bottom might be the most impressive thing I've seen him do. Not because everything else isn't, but that one part is like his master stroke genius. Like, he figured out, oh, if I trim it with a surface and I do it this way, that is super, super cool. So take note, guys. That's a really good one. Okay, I know, this has been really great. Let's just see a general finished product and tell us how, a couple of the finer points and things that we want to take away from this.
Okay. So the rest of it, as you get to the bottom here, it does a light rebuild. Oh, so it's about leaving behind the concept or the idea. So obviously you'll see some radii in there. You see some other features that just sort of help clean up those surfaces when it comes to machining this. So you'll see, obviously this is the company name, but what you need to understand is because that surface changed, this is actually the home surface. This is that original.
Oh, so you have those words actually traveling with that home surface, and it's just being machined away. Okay, that's amazing.
Whatever you finish the starting blank in, you're framing it with your post-machining detail. And that allows you to maintain. So let's say you did that burnt titanium look. So you're going to have that blue to purple to tan, and all of that starts to blend into the actual layout or graphic of the brand.
That's massive.
So and we'll be able to show you. I mean, we can go to their Instagram page if you want, or I'm not sure if they have product photography up on their website yet, but there's some other features in here that went a little further into the custom aspect of what these were.
That's amazing.
So,
well, what we're going to do, we're going to put this as part of a link so that people can go and see that for themselves and maybe purchase it if they want to, spice up their vehicle. I want to wrap up. I want to thank you for your time. I want to say that I learned some stuff here at Design Point. We try and support our customers, and some of them have these expertise in manufacturing or design or all these kind of different things, and they're doing things that are, I'd say, power user, cutting edge, super exciting stuff. So I wanted to just take a moment of your time to share with the world some of the things that I thought was super cool, and your experience honestly, we should almost start paying you for your time because of how much some of the master class tips you're giving us. So I'm going to pause there. Is there anything else you want to say as like a advice, or anybody watching what you want them to know?
Basically, there are a lot of CAD software packages out there. I've worked with a lot of them, but SolidWorks, as far as transitioning to your manufacturing world or real world application, I've found the most joy and capability in this software. So when it comes to getting an idea out to the real world, you can almost do it seamlessly with this program, and it's not something that you need to be intimidated about. There's no wrong way to do it. Yeah. There is an elongated way, and then there is a short way or an efficient way. But the way that you use this program is almost intuitive to you as a designer or you as a developer. You just need to learn it. It's a program language, just like everything else. If you learn it, the more you get to know it, the more you'll realize, why didn't I learn this earlier? With all the other programs that I learned, this was by far the funnest, the most enjoyable, and it just keeps getting better as they keep coming out with new features and new ways to control configurations or just overall design. So it's pretty awesome.
I love seeing what you've done. I'm excited for what you're doing as a designer. You've got your own company now that you're starting, and that you've started to, you're almost like pumping out these custom designs for these customers and companies, and you're just working on this kind of stuff. And I'm really happy and proud to have you as a customer, and I'm glad you're finding so much value in SolidWorks. We want you to continue to find that value, and so we're here for you. But just thanks for your time. I think just like some of the advice and some of the experience, it's just encouraging. So thank you so much.
Thank you. And I'm not sure if I mentioned it before, but the company that I started is Reut Design LLC, but that's reutdesign.co. On Instagram, there's a couple of things on there as well. Sure. But yeah, I mean, it's been really fun just to be able to talk through some of this, and it's just enjoyable to hear that feedback. So I appreciate it. Thank you, sir, so much.
You've got a lot to be proud of, and please, if you have any interests or needs, go check them out. We're super happy. We want our customers to be doing well. So that wraps up our power user interview. If you would like to be a power user interviewee, let me know. I'd love to talk to you. I'd love to see what you're doing. If you don't want to toot your own horn, just we have these CSM visits where we like to get to know our customers. We want to see what they're using the program for. We want to support you the best we can. We know that there are other options out there, and we want to make sure that you get the most bang for your buck here at Design Point. So thanks so much, Andrew. Thanks to you guys that are Design Point customers. At Design Point, where more is possible, we really try and live by that with everything we do, and believe it, and we're here for you. So thanks for taking the time to watch this, and we really look forward to more interactions with you guys. So thanks.